and you're monitoring the temperature all the time. I think what's also very interesting is you have a certain curve that you use for the frame. Maybe you can tell us about that. I saw that in the preparation now. It was like totally exciting.
Well, this is sketch about the refueling process in general. So this is the point where you connect the nozzle to the vehicle, then you push the start button, then you have a pressure.
So this is actually a refueling process as it happens over time.
Over time, yeah.
So here we see the pressure on the one side, and this is the point where the vehicle is already connected, the hose is in, and then the person refueling, he or she, presses the start button. This is that. Then what happens? Yeah.
Then there is then the hose is pressurized, so there's a pressure surge. So you have here the connection pulse, and then there is a leak check ongoing. And during this leak check, the station is measuring if the connection between the station and the vehicle is good, and there are no leaks.
Yes.
This is in a time frame of a couple of seconds.
Okay.
And then afterwards, this small pressure surge is for detection of the vehicle size or the tank size if it's not transmitted by the infrared, and then the refueling initially starts at this point. So this is the pre-fueling process.
How long does this first part take?
It's a couple of seconds, 10 to 20 seconds.
10 to 20 seconds. Okay. So at the beginning, you're doing check that the connection is fine, and also actually this is very interesting. With the just putting pressure on the pipe and measuring what happens then with the mass flow, so you can actually determine the size of the tank of the vehicle, which I found that very interesting. And then you go on to ride this curve. Yeah,
and then the yellow curve is then the temperature inside the vehicle tank, and then to manage not exceeding the 85 degrees or staying still on the safe side below, you have to control the flow rate or the pressure increase more or less in the vehicle side, in the vehicle tank. So this is then that the hydrogen is flowing in a manner that the average pressure ramp rate is within this pressure corridor and these boundary conditions. And this is all. Well, currently there are many protocols from the SAE standard, the Society of Automotive Engineers, and there is also the Clean Energy Partnership having protocols for cooled and uncooled refueling. These are the main standards currently, and these are safe standards to have fast and reliable and safe refueling process.
So like with the SAE, I think it's J2601 that we currently have. You get essentially this flow from the protocol. This is what they outline and say you must do it in this way. So it's safe. And then you go on to ride, to fill, and then you do a leak check again.
Well, here this is the point where we have seen before, where the pressure equals in the storage tank and the vehicle tank, and then where you have to change to the next bank.
Okay, that is the cascading. Again, I think if we explain cascading is a lot to explain. We have another video about that, but it's...
And in between this, there is another leak check, or it's possible to do another leak check in this one.
Okay. So there, and then you go on to the next tank system, and then you go on to the next storage tank system until you reach the end, and you're monitoring the temperature all the time. Okay, so we've mentioned JAE. What is? I've also heard high flow and standard flow. What does that mean?
Well, currently, the more standard flow is the equipment allows up to, or the protocols up to 60 grams per second.
Yes.
This is the standard flow. There are protocols in development for higher flow rates up to 120 and even higher, because for future developments, they are looking for heavy-duty, long-distance or long-haul trucks and ships and trains, which really need a high amount of hydrogen to shorten the refueling time. Another topic to shorten the refueling time is to chill down the hydrogen.
In the storage already?
No, before dispensing.
Before. Okay. We saw this in your graph. The more we chill here, the faster we
can. So the protocols standardized chilling temperatures at D20 and D40 are the most famous or most common ones.
Yeah, -40 degrees.
It's minus 40 degrees and minus 20 degrees. So you chill down the hydrogen, so you avoid that when the curve is going up to reach the 85 degrees.
But if I chilled more, I could fill faster. Is this correct?
That's correct. Yeah.
Okay, but probably that cost me more energy to do this.